Hello there. I hope you're doing well. So I want us to go through this paper. This is Physics 0625, paper 2, February March, which was done this year. That is 2024. It was just released a few days ago. So I thought I was going to be the first one, but I think someone has beaten me. But being that you're watching it, this is the first time you're seeing it. Or maybe you know my teaching method and you like it, which I really appreciate. Throughout this video here, I'm going to show you how to answer some of the questions. In multiple choice, there are some questions which are easy to do, or they're just some words which you're supposed to just to select. Please don't waste time on them. If you can able to use elimination method, do that as fast as possible. If your answer is convinced that the answer is A, why are you reading B, C, D? I'm not saying that you don't need to read them, but if you're convinced the answer is, there's some questions which are very obvious. Like, for example, what is the unit of distance? And then you find that the first there is meters. The rest are kg, what. Why are you reading the rest? Pick the answer. Let's continue. Where you can use elimination, make good use of it. If, let's say, I make a mistake or you feel like there's a better method of solving some of the questions, maybe the one that requires maybe mathematical or reasoning, please share with us in the comment there. Someone may go to benefit. All right, let's start without wasting time. So question number 1, a student has a measuring cylinder containing water and also has a balance. Which of these could be used to find the volume of a small metal sphere? She has no other apparatus. This question is very familiar. It has been said before. This is the first time. If you've been doing papers, you must have collided with this. So for us to measure the volume of a solid only, we need a displacement method. That means we will only need a measuring cylinder that is containing water, as you can able to see here. So what you'll do is to record the volume V1 before you put the solid. When you put the solid, there will be a upward increase, there will be an increase in water level. Let's call it V2. So to find the volume of this small metal sphere, we just do what we're doing here. So that will be V2 minus V1. So the answer B is the correct one. Number 2, the diagram shows a solid object on a flat surface with two forces acting on the object. What is the resultant force on the object? So resultant force is a single force which has the effect of all the forces acting on the object, meaning that these 3 Newton and 4 Newton, there is one single force that can be replaced by all of them, and they still have the same effect as these two that are here. So the forces are acting in a different direction. If you take this side to be positive and this side is negative, that means we'll have -3 Newton plus positive 4 Newton, which will give us +1 Newton. And the +1 Newton here, the positive just means that it's in the direction of the 4 Newton, which is to the right. So our answer is 1 Newton to the right. The other simple way is just when forces are acting in the opposite direction, just take the larger force, which is 4 Newton minus the smaller force, which is 3 Newton. That will give us 1 Newton. The 1 Newton will be in the direction of the larger force, as easy as that. Number 3, a ball is falling towards the ground. Which transfer between energy stores is taking place? So when the ball is falling, at the highest point, of course, we'll be having the highest height. That would be kinetic energy. So GPE is given by mgh. So because mass and g for the same object is constant in the same environment, so the greater the height, the higher the GPE. And because as it is moving downwards, the speed is increasing, that means GPE is being converted to kinetic energy. So best answer here is C. So if, let's say, talk about elastic energy is maybe after it has bounced, because now at this particular point down here, there'll be deformation. So if you want maybe something in full, it will be GPE to kinetic energy to elastic potential energy and also thermal. So during the change of shape, there's usually also thermal energy loss. All right, number 4, which row contains one scalar quantity and one vector quantity? So quantity 1, so this is just a list of so scalar quantities. All scalar quantities, they have only magnitude, while vector quantity, they have magnitude and direction. On the screen, you can able to see the list of for your reference. So for this, A is correct. Energy is a scalar quantity. Velocity is a vector quantity. If you look at part B, just to confirm, mass and time, those are scalar quantity. Momentum and weight, all these are vector quantities. Distance is a scalar quantity. Temperature is a scalar quantity. So the answer is A. Number 5, the table gives data about 4 liquids, W, X, Y, and Z. Liquids, so we have the liquids, we have the masses, we have the volume. None of the liquids mixes with any of the other liquids, meaning that they have different densities. All the liquids are put in the same container and settle to form 4 separate liquids. Anyway, the mixing of the liquid doesn't mean that it doesn't just depend on the density only, but density will play a role here so that we can know which liquid is at the bottom, followed by which one, the way you can able to see on the diagram here. So here, density is given by mass divided by volume. So that means that we'll give our answer here in grams per cubic centimeter. So this will be 10 divided by 10, that will be 1. 20 divided by 15, that will be 1.3. 30 divided by 50, that is 0.6. 40 divided by 50, that is 0.8. So we can see which one is so if you're supposed to plan, that will be the one at the lowest here will be X at the lowest point, followed by 1, which is W, followed by 0.8, which is Z, followed by 0.6, which is Y. So which statement is correct? W forms the layer below X. W forms the layer below. That is wrong. W is actually top of X. X forms the top layer. That is wrong because X is the bottom layer. Y forms the bottom layer. Wrong. So automatically, without even reading, this should be correct. There is no other choice, none of the above. Number 6, a weightless beam is balanced on a pivot as shown. Forces P, Q, and R act on the beam. Which equation is correct? So we have this. So this is about moment. That is moment. Moment is force times distance. So if you talk about distance here, so if you want the moment due to the P, moment due to P will be P times D. Moment due to Q will be Q times B, because we are talking about force times the perpendicular distance from the pivot. The moment due to R will be R times A. So all this, for them to balance, you look at each force here. Force P, if it is the only force acting on the on this weightless beam, then it will make the beam to rotate in an anti-clockwise direction. If you look at Q, if Q is the only force that is acting, assuming that this is the only force that is acting, it will make it to rotate in a clockwise direction. R will also make it to act in the clockwise direction, meaning that Q and R are acting in the same direction. So therefore, moment due to P should be equal to moment due to, so that is Q times B plus R times A. So we check which one matches this. And if we look for this, we'll able to realize that our answer is D. How is it D? Because if we have P times D minus Q times B, this should give us R times A. Just from here, just take this product here, transpose it that side. All right, number 7. An object is moving at 3.0 meters per second. A force acts on the object. After a time, the object is moving at negative 4.0 meters per second. The mass of the object is 5.0 kilogram. What is the change in momentum of the body? All right, so momentum is given by mass times velocity. If let's say we talk about initial momentum, so final initial momentum I is mass times initial velocity. Let me use V here for final velocity, so I'll follow that one this. So change in momentum is mv minus mu, the final momentum minus the initial momentum. Mass is 5, so I'll factor it out because this is like m into v minus u. So m5 into final velocity is negative 4.0 minus 3, and that should give us 5 times minus 7, which is minus 35, negative 35. So our answer is A. The diagram shows a column of liquid. The pressure due to the liquid at the bottom of the liquid is 6,000 Newton per meter squared. What is the density of the liquid? So we know that pressure in fluids, for particularly liquid here, is given by H rho G, meaning that if we want density will be, you divide everything. Let's just make it easier. So if you want density, you divide both sides by Hg, so that this cancel this cancel this. You remain with the density only. So therefore, density is pressure over Hg. So this will be pressure that is 6,000 divided by this H here must be into meters. So you convert, that will be 0.5. You multiply by G. G we have been given as 9.8. This will give us 1,200, but let's confirm from the calculator. So 6,000 divided by 0.5 times 9.8. That gives us 1224. Into two significant figures, the answer is B. All right. Which statement correctly describes a change of state? A change of state of matter. If you refer to this graph here, you can able to see that the change of state. If you look at this one here, L to G or G to L, this is when liquid is changing to gas or gas changing back to liquid. At between S to L, that is also a change of state between liquid to solid or solid to liquid. So those are the change of state. So if you look at this, a gas condenses to form a liquid. This should be correct. Of course, automatically during condensation here, condensation between now from G to L. But anyway, let's look at this. A liquid melts to form a solid. A liquid doesn't melt. A solid condenses. Solid cannot condense. A solid boils. So the answer is A. Number 10. The diagram shows a pan used for cooking food. So there's a pan at the base of the pan, handle of the pan. Which row is correct for the materials used to make the base of the pan and the handle of the of course, the handle here, you want something that doesn't conduct heat. So you will need a poor conductor of heat, which is most likely this or this. But then now we're going to, and then the base of the pan, you need something that can able to, which is a good conductor of heat. thermal conductor. So that is why our best answer here is, or rather the correct answer is B. Number 11, solar heating panels consist of pipes carrying water that absorbs radiation from the sun. Which texture and color is the surface of the pipe so that the temperature of the water rises at the quickest rate? So solar panel, this is just an example that you can able to see, but the pipes you're being told about is inside the solar, this solar panel here inside, but then you need something that is good in absorbing heat. So dull black is a good absorber of thermal radiation, followed by dull white. Shiny black is a good reflector. Shiny white is 100% good reflector of heat. So when pollen grains in water are viewed through a microscope, they are seen to be in continuous rapid random motion. What causes the pollen grain to move in this way? This is about Brownian motion. This is about Brownian motion. So if this is the water molecule, this yellow one, sorry, if this is the pollen grain molecule or particle, then these tiny dark or black particles we are seeing represent water molecules. So when you see pollen grains moving in that way, is because there is some uneven. Uneven means there's random. So there's random bombardment or heating of the pollen grain by the invisible water molecules. So the best answer here is C. Why not B? Bombardment by a single molecule of water. There are millions, billions of water molecules. So it's not just one. Convection currents in water, collision with another pollen grains, not really. That is not what causes this rapid random motion. Number 13, a circular flat bottom dish contains 100 cubic centimeter of water. Students are asked how to increase the rate at which the water evaporates. Before I look at their suggestions, to increase the rate at which water evaporates, first, you can increase, use large surface area of the container. That is number one. You can increase drought or wind. You can also increase the temperature of the surrounding. So increase in temperature of the surrounding, there's just some. All right. So if you look at this, number one, pour water into a flat with a larger diameter. So larger diameter, that means there is large surface area over which evaporation can able to occur. This is a point. Cool the dish and water. If you cool, that means temperature will be down. If temperature is down, the rate of evaporation decreases. Create a current of air over the dish with a fan. A fan increases drought or wind. So the best answer here is 1 and 3. But then now, because of this evaporation here, how does evaporation occurs? Evaporation is whereby most energetic molecules or particles escape from the surface of the liquid. And what is the effect of this? This is leaving behind molecules of generally low kinetic energy. So that is how evaporation occurs. And then this also explains why when there's evaporation, it causes something about cooling effect. That is how evaporation causes cooling effect. All right, number 14, matter consists of very small particles in a continual state of motion, which will describe the behavior of particles in a liquid. The forces between the particles, so it is either strong or weak. Strong or weak will depend on whether we are comparing with a solid or liquid. But then now, to see exactly, because if you're comparing the force between the particles, if you compare with that of the gases, then it is very strong. If you're comparing with the solid, then it is very weak. But then now, the motion of the particle will help us to see which one. So molecules within liquid, they don't vibrate in fixed position. So I'll take this one out. This is in solid. They move randomly at high speed. At high speed, this is generally for gases. Automatically, we remain with our answer as B. That is how you can able to use elimination method to respond to some of these questions. Number 15, the diagram shows the equipment used in an experiment in the heating of aluminum. So we have a heater here. We have the aluminum. There's a thermometer. Then we have data here. Okay. The mass of the block. The specific heat capacity of the aluminum block has been given as 900 joules per kilogram per degree Celsius. What is the maximum possible temperature rise in the block? So here, there's something supplying heat. This is where we do an assumption. We assume that if there is no heat that is lost to the environment, then heat supplied, the heat supplied by the heater is equal to the heat gained by the aluminum block. The heat supplied by the heater is given by power times time. Heat gained by the block is given by MC, change in temperature. We don't have power, but we have current. We also know that power is IV. So we'll have I times V times T, which is equal to MC, change in temperature. Once again, because we want the rise in temperature, so we'll divide both sides by MC. So that goes, therefore, change in temperature, which is the rise, is given by current, that is 12 times, okay, that is potential difference, the voltmeter reading. So 12 times I, which is 5, times T, which is 300 seconds, divided by M, mass is already in kilograms, 0.0 times C is specific capacity, which is 900. So we do a calculation, 12 times 5, that is 60 times 300, divided by 0.8 times, we get 25 degrees Celsius. All right, number 16, the diagram shows a wave displacement from undisturbed position against position along the wave. Which dimensions describe the properties of the wave? So this is just a question about recalling, because you know that wavelength is either crest to crest or trough to trough. Wavelength is the distance covered by one complete wave. So Q is for the wavelength, R is for the amplitude. So we look for that. So R is amplitude, Q is the, so that is correct. Which law describes some characteristics of an image formed by plane mirror? Number one is, if you can able to refer to this, the distance, the image distance is the same as the object distance. That means the object is as far, the image is as far as from the mirror, is as far from the mirror as the object. Also, the image formed is virtual. Virtual means that it cannot be formed on a screen. And then image size is equal to the object size. So let's look at that. So it cannot be real, so that is out. Virtual, it is never diminished. Diminished means it is smaller than the object. So our answer here is D. The range of audible frequency of elephant is 10 to 12,000 Hz, and for horses is 55 to 33,000 Hz. Which statement about the range of audible frequency for healthy human ear is correct? So for healthy human, we have 20 Hz to 20,000 Hz or 20 kilohertz. So, all right, let's compare. So the human can hear all the sounds. No, it cannot hear all the sounds because here this is 10, human cannot hear less than 20. So that is wrong. The human can hear all the sounds heard by elephants. Elephants, no, that is wrong because this 10 is less than 20. Human can hear all the sounds heard by horses, but not horses can hear. 33 is above 20, so that is not correct. Our answer must be D, even before reading. Okay, yes, sir, that is how you save time. Huh? All right, so an object is placed in front of a plane mirror. The ray diagram shows the reflection of one ray of light from the object by the mirror. Where does the mirror form an image of the object? So, of course, it will usually be in the straight line because this ray here, if you extend it, if the eye is somewhere here, then the ray will appear to have come from behind the mirror. So without wasting time, yes, without wasting time, the answer must be A. The answer must be A. So remember, we don't put here the dash because the real ray, this is the ray, and this ray here is coming here. To the eye, this ray appears to have come from behind here. So that is what happens. So A is our correct answer. Light refracts as it enters the glass from air as shown. Which expression is equal to the refractive index? So refractive index generally is given by sine I over sine R. Sine I is the angle made by the incidence ray with the normal. This is the I. And this I here, you can able to see clearly, it will be 90 degrees minus theta, theta 1. And then R is theta 2. So that means we have C as the correct answer. 21, light traveling at a speed of 3.0 times 10 power 8 meters per second strikes the surface of a glass block and undergoes the refraction as it enters the block. So the diagram shows a ray of this light before and after it enters the block. What is the speed? Speed of light. So when there's a refraction, to find speed, refractive index is given by speed of light in air or vacuum over the speed of light in that medium. But I don't have refractive index, but I can find refractive index using this method, sine I over sine R. So that means that will be sine of 55 degrees divided by sine of 33 degrees. Do that. Sometimes some students forget and then write 55 over 33, which is very long. They use refractive index as I over R, and they feel like because they were lucky one day, so they think that can also work. It does not. So sine 55 divided by sine 33, that gives me 1.50. 1.50 into 3 significant figure. So therefore, from this formula, you can see 1.5 is equal to 3 times 10 power 8 over V. Therefore, V will be 3 times 10 power 8 divided by 1.5, which should approximately be 2.0 meters. All right. Number 22, which row about converging lenses and diverging lenses is correct? So I have some images here. You can able to see there is a converging lens which is called a convex lens. So converging, you can able to see rays parallel to the principal axis. After refraction, they pass through a particular point which we call the principal focus. There was, I think, a question like that in Feb 4. Those who did 4.1. So diverging lens, this is whereby rays parallel from far. After refraction, these rays are refracted such that they diverge. That means they tend to move away from each other. So they diverge, and then to the eye, they appear to have come from behind the lens. They appear. Anyway, so there's a whole topic about that I've done. And some of these lessons you can always find from our website, InnoLearn Network, InnoLearnNetwork.com. So I've just given you a free resource place. Now, converging lens always produce inverted images. This is wrong because at one particular point, if this is, let's say the focal point is somewhere here, and then you put an object somewhere here. So if the object is between the principal focus and the lens, then there will be a virtual image that is produced, which is upright. So that is wrong. Can be used as a magnifying lens. Yes, that is correct when this one happens. Can be used to correct short-sightedness. That is wrong. It can only used to correct long-sightedness. Can produce real and virtual images. This is correct. It can produce both real and virtual images. Okay, so now let's look at B and D. Do not have principal focus. This is very wrong. Principal focus must be there. So that means our answer must be D. Can be used to correct short-sightedness. That is for divergence, diverging lens. Yes, correct. All right, number 23. A child rod X is placed on balance and another rod Y is brought close to it as shown. So which combination of charges will cause the change in the balance that is reading, or the balance reading as shown above? Anyway, so initially it was 45.3, but then there will be an increase. For there to be an increase, that means that this object must feel that there is some kind of extra force that is acting, and that can only happen if there is a repulsion between Y and X. That means they must have the same charges. So negative, negative, I will mark this. I hope that there's no positive, positive. Anyway, there's no positive, positive, so our answer is correct. That is repulsion. If let's say the reading was slightly less than 45, that means it would be attraction because it tends to be attracted upward, be pulled upward. That could have worked. Anyway, number 24. What is the unit of potential difference, PD? This is unit of current. This is unit of charge. This is unit coulomb per second is unit of current, because current I is this over this. So that is coulomb per second. Coulomb per second. So our answer is volt. Number 25, the diagram shows a transformer. What is the output voltage? So transformer, there are two transformer equations. There is, when you say that for an ideal transformer, there is no power loss. So if there is no power loss, it means that the power in should be equal to the power out. So if this is true, that means that current in the primary times voltage in the primary, this secondary times this. This is one equation, but we don't need to use this since we don't have current. So that means we'll go to transformer equation 2 about the turn ratio, that we have Vs over Vp is equal to Ns over Np. This shows that the number of turns is directly proportional to the induced voltage in the secondary coil. So we want output voltage, which is the Vs. So Vs will be Ns times Vp divided by Np, because you can able to see I just multiply both sides by Vp, yeah, by Vp. That's what I've done. Then this will cancel this, so I have Vs remaining. So meaning what I will do is to use the values that are there. So Vs will be Ns. Ns secondary is 115. So that is 115 divided by Np, which is 550. We multiply by Vp, that is 22. So 115 divided by 550 times 22,000. That is 4,600 volts. If someone asks you which type of transformer is this is a step-down transformer. This is a step-down transformer. Why? Because the number of turns in the secondary is less than the number of turns in the primary, or the output voltage is less than the input voltage, because that is the work of the transformer. All right, so let's continue. Now, the diagrams show two arrangements of a pair of identical bar magnets. So diagram 1, diagram 2. So diagram 1, there is a repulsion. So when there's a repulsion, this is what we expected, though this is south, but repulsion at the center, where this P is a neutral point. And then for this NS, that means there's going to be attraction, that's going to be like the field pattern. Okay. So 3 points PQ and R as shown. At which point is the magnetic field due to the magnet's weakest, and at which point is this strongest? So it is weakest at the neutral point. So it is weakest at P. Whenever there's a repulsion at the central point, that is P. So that means C and D are out. Then the strongest point is where the magnetic field lines are closer to each other. So it is stronger at the pole. So that is R. So our answer here is B. A nichrome wire P has a length 1.0 meter and a diameter of 1.0 millimeter. A second nichrome wire Q has length that and diameter 2.0 millimeter. Which statement correctly compares the resistance of Q with that of P? There's whether it is a quarter, a half, the same as, I think reasoning may take a lot of time. The sure bet here is calculation. So let's see. Resistance is directly proportional to length, but inversely proportional to area. But if you look at area of a circular, because if it is a wire, we assume it is cross-sectional area is circular, so that will be pi r squared. R is d over 2, meaning that this is pi d over 2 squared. That means it is pi d squared over 4. Because pi and 4 are constant, so I will ignore them. So I'll just say here that R is directly proportional to L and inversely proportional to d squared. So instead of area, I will just write d squared here. That means R directly proportional to, I'll just keep maintaining the symbol. L is 1 meter. Diameter is 0.001 meter. So that they cancel out. But this is now squared. This is now squared. So this should give us something. There's 1.0 times 10 power 6 per meter. I have for this is RP. RQ, I'll use the same formula, this one here. L is 2. Diameter is 0.002 into meters squared. This will give me 5.0 times 10 power 5. If you want to know how they relate, this will be, if I take 5 power that, so we'll realize that RQ is a half of RP. RQ is a half of RP. So let's see. A quarter RQ is 1/2 the resistance of P. Q is half. Yeah, the answer is B. Okay. A student has two resistors. One resistor has a resistance of 2 and the other has a resistance of 40 kilo ohms. Which statement is correct? I think this question just want to confuse the kilo here, because 40, that is a 40,000. And I'm sure someone must have made a mistake because of that. So when they are connected in parallel is 1.9, 42. If they are connected in series, that means you add, to find the effective resistance, you add, but I'm not seeing anything here. That means they must be in parallel. Because series, I expect something like 40,002. But that is not here. But I know someone made a mistake, just added 40 and 2 and thought that the answer was D. These guys are clever. Let's find out if they're in parallel. If they're in parallel, when we have two resistors in parallel, we just be clever, use the product over the sum. So that will be R1. R1, that is, so 2 times 40,000 over 2 plus 40,000. That will give us 80,000 divided by 40,002. This will give us 1.99, approximately 2. The answer is that. Interestingly, if someone make a mistake and then add, you will know that this is 40,000, but so you may make a mistake and then you write here 42. If you write here 42,000, then you will get your answer as 1.9. So be very, very careful. All right, let's continue. Number 29, in which circuit do both lamps light? In which circuit do both lamps light? All right, this question is asked because of this special component called diode. So remember, a diode is a special type of a resistor which allows current to flow in one direction. So it offers very high resistance in one direction and very low resistance in the other direction. So when this arrowhead here, if let's say current is supposed to flow this direction, then it will not allow current to flow. Detail of how a resistor, a diode works, even practically, you can check on the link above. But to avoid this being distracted, you can always search in the YouTube, in our YouTube channel, the same content here. All right, anyway, let's find out. Current is supposed to flow in this direction, but it's blocking. So A, no, the lamp will not light. Current flows in this direction, but once it comes, it is blocked, so there will be no current here. In C, current flows here, but then now this lamp will light. Definitely this lamp here will light. Our answer is C. Let's just check on D. Current will flow through lamp 1, but there will be no current in lamp 2. So that is how we look at it. Number 30, an isotope of strontium has the nuclear notation of SR. So the nucleons is 84, proton number, that is 38. So how many protons and neutrons are there in a nucleus of isotope? So protons is 38. Remember, this nucleon is neutron and proton, so we just take 84 minus 38, which is 46. So our answer is A. A student is investigating the count rate of a radioactive substance. How must he adjust his reading for the background? So remember, background is always that low ionizing radiation, which is always present. So let's say that before the radioactive source, maybe the count rate can be something like maybe 20 counts per second. So if we have 20 counts per second, And then let's say now when you bring the radioactive substance, it shoots to, let's say, 50. For us to find the count rate for this active radioactive substance, then we correct it. How do we correct it? We minus the background. So 50 minus 20, we get 30. So how do we do that? We do C. Subtract the background count from his reading. What occurs during nuclear fusion? So during nuclear fusion, this is where light atomic nuclei, some atomic nuclei, they join together. They join together, like for instance, when you have hydrogen, isotopes of hydrogen joining together to form helium. That is a nuclear fission which occurs in the stars. All right, two light atomic join together and emit energy. Two light atomic energy join and absorb energy. So heavy CD, they're not heavy, they're light. So for the sun to be producing heat or thermal energy, all those energy, that means there's emission of what? Emission of energy. A, because it's a source of energy. So if it is a source of energy, it must be emitting it. A beta particle enters a uniform magnetic field directed into the page and deflected downwards as shown. So which direction of the electric field will deflect an electron downwards? So if you look at the electric field, if we have a positive here, this is a positive plate, this is positive plate, and this is a negative plate. Beta particles are negatively charged. That means they are repelled by negative. But then the electric field is directed from positive to negative. So the direction of the electric field will be from bottom to up. That is why it will be what? Up the page. The radioactive isotope radon is an alpha emitter. During this radioactive decay, an isotope of polonium, PO, is produced. How many neutrons does a nucleus of the isotope of polonium contain? Most students will make a mistake. They will work out for the radon and will get it wrong. So what you need to do is that we have radion 222, that is 86. If it is a go alpha, so polonium here, alpha decay, there will be alpha here is a 4, 2. When we add this should give us 22. So that will be 218. And this one here should be 84. So now if I take 218 minus 84, it will give me the number of neutrons. So 218 minus 84, that gives me 134. But if you use this directly, you will get 136. They don't want to disappoint you, so you will get your answer. But be very careful when the questions are very direct like that. But I'm not saying that you overthink. So please, it's very important. Which statement gives two safety precautions to take when a person is working with ionizing radiation? So of course, generally, there are so many points about this. Keep distance. Reduce the time of exposure. These are some of the points. Store them in a lead container. Wear something like a photographic film badge, to help with that. So let's look at this. Decrease time exposure, decrease distance. No, decreasing distance means you are coming closer to it. The answer is definitely B. Decrease the time of exposure, increase the distance between the person and the source. I don't want to read C and D, so our answer is B. Aye. You don't have time to waste in multiple choice question, but for now, I take some time because I'm teaching you. 36, which list correctly shows the planets in decreasing order of distance from the sun? So you can able to see we have Neptune the farthest, Uranus, Saturn, Jupiter, Mars, Earth, Venus, Mercury. So we look at the list, the one that is in order. So Jupiter, Saturn, that is order is not clear. Jupiter, Saturn, that order is not clear. Neptune, Uranus, Saturn, Jupiter is very, very clear. You can able to refer from the diagram just here. I don't want to refer. So please, always, that is something that you can able to master, whether you want to write a song, that is up to you. Number 37. The sun radiates most of its energy in 3 regions of the electromagnetic spectrum. In the pie chart, region 1 is infrared radiation, which is the highest. Region 2 is the visible radiation. The third one, this must be UV. Oh, because those are the most one. And wonderful. That is just a recall question. There is no discussion. Just get it from your notes. All right, so 38. The diagram shows a comet moving in an elliptical orbit around the sun. At which position is the comet moving with the high speed? The comet is moving around the sun because of gravity. And gravity is strong when they are close, so it is moving the high speed at point A. So let's continue with that. 39. The nuclear reactions in the sun release large quantities of energy. We statement about the process is correct. So that is about process of fusion. So it involves fission. Fission is the splitting. So AB is out. It involves the fusion of helium. No, helium is the product. So our answer must be D without reading. Anyway, fission of hydrogen to produce helium. Okay, number 40. The table gives data about 4 planets in our solar system. The mean surface temperature, Uranus, Earth, planet X, Jupiter. Sorry, planet Y. Now, the surface temperature may not necessarily align to how far they are away from. So surface temperature, also the temperature generally may not align, but it may depend on the content and the size. You can able to see, if you look at this table here, Jupiter is very big. So, and the surface temperature is even less than, you see, the highest for the Earth can even be 58 some point. Look at Mercury, can even be 460. So it's not about the size. Surface temperature, you see, it is so big. So it is hot at the center, not even hot compared to Mars. So that data, you just need to work it out. So Saturn is about -140. Planet Y is about -140. Mars is about -65. So Saturn is, you can able to see clearly, is -140. So the answer here is going to be A. All right, I want to wish you all the best. If you have any question, do not forget to check them out. Please, if this video was good for you, you know what to do. If you don't want to subscribe, the least you can do at least to share with your friends. Bye-bye.